Solving indeterminate members requires more analysis than blindly following a procedure. Check how this next system is solved here in Mechanics of Deformable Bodies. A homogeneous slab weighing 750 kilonewtons is supported by 3 rods which have similar material and similar cross-section. Originally, the attached slab is horizontal. We are to determine the axial force in each rod. Let's start with generating equilibrium equations, so we draw a free body diagram of the bar. The 750 kilonewton weight is at the center of the slab, which creates rods to be in tension, and we will tag each as P of A, P of B, and P of C. With 3 unknowns, we should generate 3 equations. Using equilibrium equations, with the summation of vertical forces, we get P of A plus the load of B and the load of C equals 750 kilonewtons. Label this as equation 1. Create another equation with summation of moments. Take the moments from A, that is, P of B times the moment arm of 3 meters, and P of C with 5 meter moment arm equated to 750 kilonewtons with moment arm of 2.5 meters. Meters will cancel out, and the simplified equation is 3P of B plus 5P of C as equal to 1,875 kilonewtons. This is equation 2. Let's analyze the system further. With a load of 750 kilonewtons and the uneven spacing of the rods, the slab will then be tilted like shown. Measuring the deformation, we note that the deformation at point A will be greater than the other 2 rods as it carries more load. Now that we have analyzed the deformations, how do we relate them to each other so that we can create the third equation? Draw a line from the smallest deformation, then convert the other deformations. By doing this, we create a triangle which we can use ratio and proportionality. Deformation of B is then converted into deformation of C plus y sub 2. Take this as equation A. Deformation of A is then deformation of C plus y sub 1. Label this as equation B. Then we work on similar triangles to correlate y1 and y2. So by ratio and proportion, y sub 2 is to 2 meters and y sub 1 is to 5 meters. Y sub 1 is then 2.5 of y sub 2. This we make as equation C. Use simultaneous equations on A, B, and C to come up with the third equation. First, from equation A, extract y sub 2 as deformation of B minus deformation of C. Let's label this as A prime. We also use equation C into equation B, so deformation of A becomes deformation of C plus 2.5 of y sub 2. This is equation B prime. Combine equations A prime and B prime. So we have deformation of A as equal to deformation of C plus 2.5 of the quantity, deformation of B minus the deformation of C. Take out quantities and have the deformation of A as equal to deformation of C plus 2.5 of deformation at B minus 2.5 of deformation at C. Deformation of A is then 2.5 of the deformation of B minus 1.5 of the deformation at C. Now we have an equation where the three deformations are related. Next in the process is to convert deformation into loads, so use PL over AE for deformation. Take note that the area and the modulus of elasticity are identical, so they can be cancelled out, creating a simplified equation of PL of A as equal to 2.5 times PL of B minus 1.5 times PL of C. Plug in the lengths where length at A is 5 meters. The length at rods B and C is 6 meters. The final simplified equation is then P of A as equal to 15 P of B minus 9 P of C. Take this as equation 3. With the available equations 1, 2, and 3, we can use simultaneous equations to solve for the unknowns. Start with equation 3 plugged into equation 1. P of A is then converted into the quantity of 15 P of B minus 9 P of C plus P of B plus P of C, and this is equal to 750 kilonewtons. Collect similar terms and have 16 P of B minus 8 P of C as 750. Or we can take P of C as an 8 of 16 P of B minus 750. This is then equation 4. Use this into equation 2, which is 3P of B plus 5P of C as 1,875 kilonewtons. This becomes 3P of B plus 5 times 1/8 of 16P of B minus 750 as equal to 1,875 kilonewtons. Simplify the equation and have 3PB plus 10PB minus 468.75 as equal to 1,875 kilonewtons, which then becomes 13P of B as 2,343.75, giving P of B as 180.2885 kilonewtons. That's the first unknown answered. Plug P of B into equation 4, so we get an 8 of 16 times 180.2885 minus 750. P of C is then 266.8269 kilonewtons. Then use both P of B and P of C into equation 1, which gives P of A plus 180.2885 plus 266.8269 as 750 kilonewtons. P of A is then solved as 302.8846 kilonewtons.